Rob Snyder. I'm a professor at Slippery University in the elementary education department. I've been there for 10 years. And the students that are here helping me are part of our NSTA student chapter. We've had the chapter on campus now for 4 years, and they do numerous fundraisers in order to pay for the bus and the lodging and so forth. Everything from science days for Girl Scouts and junior troops, as well as event staff for the Pittsburgh Steelers and Pitt football program. So they're excited to be here, and if nothing else, you're going to be able to share with each other what you're doing as well as with the people that are here. And we do have some handouts for you with these things. So the topic of today is discrepant events and how to use them to build inquiry skills, namely to get students to make predictions, look at observations, and analyze their predictions. So the one I'm going to open with here, okay, is one that I often use with a Harry Potter theme. When we talk about the fact that there's so much magic associated with Harry Potter, we try to debunk what's magic and what's real science. And one of the key things that are used in the Harry Potter series are invisibility cloaks. So we talk about that. You know, is that science or is that magic? So here I just have a test tube and a beaker filled with corn oil here, and you can see the test tube. And in order to create an invisibility cloak, I'm going to pour some corn oil in here. And you can see what happens then is you can see that the test tube disappears or becomes invisible at the bottom. Now, it's still there because you can hear me tapping on it, even though at this point you can't see the invisibility cloak. So when we talk about this, one of the things I often discuss with kids is how does this work? Okay, if it's not magic, if it is science, there you can see I made it completely disappear, even though you can still hear it here. So we ask them, what's happening here? Okay, how does this work? You want to take a guess? Okay, the easiest way to explain this is to think of something maybe you've seen before, which is if you put a pencil in a cup of water, what happens to that pencil? What does it look like where it joins the air?
It's a refraction.
Okay, the refraction makes it look bent or distorted or broken. All right, so the way this works is the corn oil and the beakers have the same refractive index. So in other words, when the light comes through these different ingredients, it comes back at the same time to your eye, so your eye cannot distinguish the difference between the beaker. When this was empty, you had a pocket of air, okay, that was in there. That pocket of air allows that light to reach your eyes at a different rate than what it's moving through your corn oil. So to make this work, you have to have Pyrex brand. Cheap beakers, for some reason, have a little different refractive index, so it doesn't work. And you have to use corn oil, not vegetable oil, to get that refractive index to make it disappear. All right, so our first student group that is up is Jen and Nicole. And I'll let them go ahead and show you the next one.
Good morning. I'm Jen, and this is Nicole. Our discrepant event is titled Pump It Up. What you need for this event is peeps. We got Christmas trees and snowmen just because it's December. And this is called a vacuum bin. It's used to, it's like an air chamber for food to keep it more fresh. So,
mostly used with cereal and other things like that you want to keep dry.
So can someone make a prediction of what they think is going to happen whenever we pump the air out of this container? What's going to happen to the peak? Can anybody take a guess? It's going to expand? Okay, well, we'll see what happens.
It does take some time, so.
Actual size. Yeah, go ahead.
Oops. So are we making some observations yet? See any difference in the peep?
Yep.
You already see it?
Okay. What happens here is, what happened to the peep? Everyone just, all at once, tell me what happened to the peep. It expanded. It got bigger. That's because as air is being pumped out of the vacuum bin, there's low air pressure on the inside of this, and there's air pockets within the peep that it has to expand to try and fill the container. So our next step is, you can stop pumping now.
You can actually get it so much air is out that the peep won't even move. It just is suctioned to the bottom. So here's the original size. Let's get him up like this.
So he got a lot bigger.
So now that he's a larger size, what do you think will happen if I release the valve at the top and allow You don't think so? Okay.
Okay, so we'll see what happens. We'll let this guy out.
Try to do it slowly.
Try to do it slowly.
So when the valve at the top is being released, the air pressure is actually increasing?
Yeah.
Yes,
air going
because
back
the air is
inside.
being forced back inside, so the air pockets in the PEEP shrink.
He's actually a little bit wrinkled and a little bit more smaller than his original size
He's seen
was.
better times.
Yeah, he's seen better times. He's aged a little bit. So this would be a great lesson to use in introducing low and high air pressure. And it's really easy, simple. You can find this at any food store, like a kitchen supply store. It's just like a vacuum. It's called a vacuum bin, and then obviously PEEPs you can find anywhere.
The PEEPs are fun because they're familiar to the kids, and you can actually buy them in all seasons now. They used to be just an Easter thing, but they have them for Halloween and Christmas.
And it's fun to see them blow.
Yeah.
So next we have Cassie and Maria.
Good morning, I'm Maria.
And I'm Cassie.
Alright, today we are going to have a balloon race. So would anybody be willing to come up and try and blow up the balloons in our bottles?
Let's get some brave volunteers.
2
in
volunteers.
here.
Anybody?
Come on, big
I know
guy.
someone's excited. Gentleman over here is excited.
Yay, thank you.
Anyone else? I'm
How
gonna
about a
give this
lady?
Let's get a girl.
You want to
Come on.
volunteer?
All
Okay,
right.
lovely.
Thank you. And we'll give
Yeah,
you
she
this.
came in wanting to be all subdued in the back, entrance, and right away you put her on the
With
hot.
the beautiful necklace like that, you cannot do that.
Alright, so in a minute, I'm going to have each of you at the same time try and blow up the balloons in your bottle, and we want to see who can blow up their balloon first.
It's a race. Wait.
Yes, it's going to be a race.
Then you'll win us
So.
Now, by a show of hands, who thinks that this gentleman over here is going to win?
I just want to get full of hot air, so I
And by show of hands, who do you think
have more hot
this lady here is going to win?
Okay, it's about half and half. We
Oh, you're
got
going
down.
quarters on both teams.
Great. Okay, you ready? All right, on the count of 3, you're going to both go at the same time. Ready? 1, 2, 3.
Go, go, go. Whoa.
All right. Whenever you run out of air.
Keep going, make it. Wow.
Whoa!
Yeah.
Look at that. Awesome. Thank you. Now, what happened over here? I'll take the bottle. Thank you. All right.
Does anyone know why she could expand her balloon in the bottle, but he couldn't? Any guesses?
There's a hole in the bottle.
All right, that's a good guess. You think we're cheating up here?
No.
Does anyone here know if air takes up space? You guys are
Yes.
right, it does.
It does. There's air everywhere, right? So yes, air does take up space. So this gentleman, you are correct. There is a secret hole in this bottle. And the bottle...
It's a rematch.
So the reason that this bottle wouldn't blow up is because air does take up space and there's air all around the balloon. So as you put more air into the balloon, the air around the balloon inside the bottle has nowhere to go. And in this bottle, it's escaping through the hole, so there's air displacement occurring. So that's why that balloon blew up and the other one didn't. So what we showed you is actually an example of atmospheric pressure. So does everyone know what atmospheric pressure is?
I only know the chorus anymore. I don't remember the verse.
Atmospheric pressure is the force per unit area exerted against the surface by the weight of air above that surface in the Earth's atmosphere. Or in other words, it's the pressure that's exerted by the atmosphere.
So it's just the pressure all around. Does everyone have any questions? Yes.
I'm going to throw one back at you.
Okay.
And the kid says, but there's a roof over this room, so how can the atmosphere be pushing down?
Huh.
You don't have to answer it now.
Jeff?
The kids will ask.
That's a whole focus on. No,
Right.
that's a
I
common
don't know, but let's find out. How's that?
That's
Very good.
All right, so
The other
next
question
up,
that kids often ask is, well, then why don't we get crushed?
Yeah.
Kids, young kids have a hard time understanding that we have pressure.
pushing out also.
Pushing out.
Right. All right, well, thank you for
And that's okay,
participating.
because, at the end, I have a discrepant event that helps explain that.
Good.
So next up, we have Cindy and Cheryl.
Cindy, I have my homework for you. I thought the assignment was to complete it. All you have is a blank piece of paper. I completed it. Really?
Yes, I did.
Where's your work?
Right there. Okay, good.
Really?
Yep.
Do you see her work?
No, I don't.
You can't go to recess until you have this complete. You know the rules, you know how it works.
And we all know good teachers do not take away recess from their children.
So, I'm not taking all
I
of
will
it.
show you. There you go. I completed it.
Oh, so you decided you'd do your science homework and your reading homework together.
Yes. With invisible ink. Some of the questions that students will ask around this time is, why does the juice make the writing appear on the paper? And the other one would be, what type of a change has occurred? This is a chemical change, and Cindy's going to explain what happened.
So basically, the juice changed the pH. What we added to this was water and baking soda in a mixture. And there was a change in the pH, which is what changed the color. Instead of the basic little indicator strips that would come in any science kit, you know, a lot of people, if you haven't been exposed to it, you get that science kit at home. My sister and I, we didn't know what they were for. We just thought they were cool. Never used them for science, just played with them. But this is more appealing to kids because I'm in 4th grade, you're in 2nd grade right now. Who wouldn't want to write with invisible ink so that it looks like they're not passing a note or something secret?
Or even doing this in your classroom, we're telling them to go home and they can actually do their homework in invisible ink.
Yeah, it's a
Something like
great
this.
motivation for them. And all it takes is a little bit of grape juice. Not afraid to get a little dirty, but a cake pan fits perfectly. And you can reveal it. They can write a message. They can do their homework. It's just fun for them. All right.
And we have, after us, is Dawn Ray.
For those of you that came in a little later, we have packets that we'll distribute and with the activity credits.
Thank you very much.
Tom, one of the first rules is you never pack it and pass them out right away, or
Right,
everyone folds
yeah.
it in.
My name's Dawn Ray. My event's called What a Sucker. I'm going to need one volunteer for it.
Don't be shy.
It's called What a Sucker?
Okay, what I need you to do is put both straws in your mouth, put one inside your cup, and one on the outside, and then try to drink the fluid. Don't cover either tip with your tongue or finger.
Oh, well.
Did you get it?
I got some.
Oh.
There's no hole in the bottom of the straw. No, there isn't. Sorry. Yeah, I didn't expect that to work.
Yeah, it's not supposed to.
It should have.
Well, normally when you do it, your mouth is like a vacuum, and the air pressure in your mouth is lowered when you're drinking out of a straw. So one straw will let you drink, but when you add the second straw breaks that vacuum,
I'll stop there. Anything else? Is it down?
Yes, you can sit down. Thank you. So it would normally break that vacuum with the second straw, but for some reason it worked.
It's describe an event.
Yeah.
And one of the important things they learn is that becomes a teachable moment to then discuss with students, okay, why didn't it work the way it was? So
So the vacuum was
clearly for
broke
some
somewhere.
reason that hole was not large enough or was not allowing.
You know, maybe a wider diameter straw.
They worked earlier. I tried them.
Oh, really?
Light on that straw?
No.
But
no,
you could
really.
use this for teaching air pressure, if it would work. Thank you. And the next person to come is Sarah and Caitlin.
Hello, I'm Caitlin,
I'm Sarah.
and today our discrepant event is called Dancing Raisins.
All you need is pop, either 7-Up or Sprite, and some raisins, and it's all clear glass.
Okay. So before doing this, I would probably ask the class what they think will happen when I put these raisins in the pot.
And as you can tell, it looks like they're kind of dancing. They're going up and down. And the reason is because the carbon dioxide is attaching in the grooves of the raisin, and so it floats up, and then once it gets to the top, the bubbles pop and it goes back down. And this would be good for asking the kids about carbonation and carbon dioxide.
You can also add some music in the background.
Get them to dance. Next we have Laura and Lena.
Wow. The idea of using the music with that is a great one because I play Heard It Through the Grapevine of California Raisins, and some of the kids will think, well, they're dancing because of the music, so I have to turn off the music to let them, test that variable to see that they still are dancing. Interesting.
Okay. Hello everyone, my name's Lena.
I'm Laura.
And today our discrepant event is going to consist of a newspaper and a ruler. And well, we're going to have to do our discrepant event on the back table just because it's larger and it will work better. But we're first going to put the ruler halfway on the table and halfway off the table. Then we're going to put newspaper on top of it. And does anybody have any ideas what's going to happen if Laura hits the ruler with her fist? Do you guys think that the newspaper is going to fly? Do you guys think it's going to shoot out, fly
Any
upwards?
predictions? I think the newspaper will rip. You think the newspaper will rip?
Okay.
A lot of times students will predict that the newspaper will fly across the room. And then we talk about with the students, if you crumple up the newspaper and put it at the end of the ruler, will it fly farther? And a lot of times they think it will. So we talk about things like that. We talk about what is holding the paper and the ruler to the table right now, which is gravity. Gravity's pulling down on the paper. We also talk about mass with the students. If you crumple up the newspaper or you spread the newspaper out, does the mass change? Just new. So we talk about all those things with the students, and then I will hit this. Hopefully it will work.
Yay!
What happened?
You just blew your science budget by
These are 55 cents at the hardware store.
My karate lessons finally paid off.
So what do we think happened? Why did the ruler break in half? That wasn't what we predicted. Any guesses? Nicole?
Because you're super strong.
Well, obviously, but besides that.
Air pressure on the paper held it.
The air pressure on the paper, you are absolutely correct. The air pressure pushing down on the paper, air pressure for every square centimeter, it's 2.2 pounds of pressure. So I would have to drop a truck on this ruler for the paper to move. There's more pressure on the paper than I could ever apply with my fist, so that is why the ruler breaks in half.
Well, if you go very slowly.
If you go slowly, the paper will rip. apply enough force so that the ruler will break on the edge of the table.
Right.
But yeah, as long as you hit it quickly, it should break.
Does it matter if you change the type of ruler?
No, actually you can do this with a yardstick, but it just needs to be wooden. And I would try it beforehand to make sure it's not like
You also have to take the metal out of the side of it too.
So
Right,
plastic, did you try it with plastic?
a plastic ruler probably would. I mean, it might work, but wood works the best because it splinters and it looks really cool when it breaks. Up next is Victoria and Sarah.
Real quick, while they're coming up, back to the Hanson raisins, you go ahead and share with them here what you do.
I take 3 of those twist top containers. I make 3 of them. One I do Coke, one I do 7-Up with a splash of Coke, and one I do 7-Up. And I tell them that they're sewer bugs that my kids found out in Delaware River. And I hold them up and I say, I do preschoolers. I say, when you flush the toilet and poop goes somewhere, I went somewhere and I got a jar of that, and that's what this is. And I'm not going to open it up. And then I take the second one and say, he's been in for 2 weeks. Look at how much clearer it is. And the third one is clear. It's been in since the beginning of school. You want to see one? And I open it up and I say, the best thing is you can eat them and you can drink the water. And I do that with my kids every year. And the thing is, don't tell the joke. Just watch everybody else that's there, because it's really, really funny, the faces of the people when you think you actually drink that. And then you talk about discrepant events and who got them.
Wow.
That's cute. I had one parent throw up when I did it. That is so cute.
This is kind of messy.
A gooey situation. Okay, right now we have a mystery mixture, and we're going to pass these out and let you kind of observe them.
Yeah, I'm pissed.
So, as you can see up here, we have a plate of it, and I don't want to tip it too much, but there's a plate here. So when you're observing your mixture,
Don't touch it. Make sure you don't touch it.
yeah, don't touch it. You can smell it. You can just watch it.
Don't
But-
taste it.
Thank you.
Think about what would happen if I took my hand and push my hand into this really fast. What do you think would happen? And when you have an idea, go ahead and raise your hand.
It'll splash up in your face.
How many people think it'll splash up in your face?
I think.
Thank you.
Does anybody else have a different prediction? Okay, do I have a brave volunteer to come up for a demonstration?
Who wants to get close to this?
Yay.
I'm really hoping it doesn't splash since I'm wearing black pants.
Okay, so
It looks dangerous, doesn't it?
It sure does.
okay, so what we want
Are
you
you
to
sure?
do is put your face
Your face.
your face down really close to it.
Right
You
next
can do
to
this.
Real close to this.
Real close.
All right, maybe next to the side, sideways,
Forget me to hit it.
All right, you gotta look out a little bit, maybe to the left a little bit. Because I'm gonna smack it right next to you.
All right, like this.
We're really hoping to
Sure. Okay, you ready? Ooh, it didn't get you, did it?
I didn't feel
Want me to
it.
do it again?
Okay, go ahead.
No splash on you. Do you know why it didn't splash on you? I mean, it's looking pretty dangerous up here, don't you
It
think?
looks really runny, and I was expecting to have you totally
I mean, it's
blow my
dripping
makeup.
all over. Well,
just been a different kind of makeover.
yes.
Yeah.
All right, so when we see it, I pull it out and it's running all over the place, right? Everybody see that? I want you to kind of move your thing around, watch it run. But if we take out our mixture and we roll it in a ball, we have a ball, right?
Does anybody want to come hold it?
Yeah, come up. Who wants to hold it?
Come hold it.
Come on up. Who wants to touch it?
Here, I'll hold it.
I already went.
Oh, yay, a fun ball to play with.
Aww. Now I'm in the way. So, yeah, I know. And then if you go like this, you have napkins.
So when you're holding it and you're moving it around, as long as you're constantly moving it around, it's in a ball, it's in a solid. But then as soon as we passed it to her, it like formed into a liquid, right? Did everyone see that? Does anyone know why this happened? Any of my smart audience?
It's a non-Newtonian fluid.
A non-Newtonian fluid. Very correct. Woo, I'll clap for you. Right. That means that it doesn't follow the properties of Newton's liquid laws, and so when we have it, it changes from a solid to a liquid. It's also a colloidal suspension, and that means that there's two phases for it. Oh my goodness. There's two phases for it because it is a mixture, but they're not. It's not solid. It doesn't like completely change the phase of it. So you can use this. I made it sound dramatic. You can use this for teaching about matter, polymers. You can also do, if you have younger kids, you can do a Dr. Seuss book. It's like the Oobleck book.
Right.
So you can use that. And you can even have them make their own Oobleck. And there's also things you can do, like you have this, but then you can have them add their own. Does anyone know what's in Oobleck? Cornstarch and water. So you can have them add more cornstarch to it and see what happens then, or add more water and see what happens. You can also add like corn syrup into it and see how that affects it. Yeah, just check it out. That's about it. So, thank you.
Just bring in your old newspapers if you do it.
Yeah. Yeah, we should put a newspaper here.
You'll be able to clean it off at the end.
If you want, you can make a ball out of your little.
Couple quick suggestions. There's an old GEMS unit that uses this, but the substance is described as coming from an alien planet. And the challenge, this is the surface of the planet. You can add a little green food coloring if you want. Put in a little mint flavoring to give it a smell as well. But the challenge is to design a spaceship that will be able to land on the surface and not sink in. And kids come up with things like pogo sticks and all kinds of stuff. So there's lots of extensions that are really possible with. And you're right, Bartholomew and the Oobleck is a great story. You know, and you can take that one and challenge them. That how can you help Bartholomew help the king? Cut the story off halfway. So a lot of neat possibilities.
And it's not just for younger kids.
Right.
Yes.
You can, yeah, I have it in the packet. You can teach like K through 8. I mean, it can go as far as you want to take it with whatever lesson you're teaching.
Sixth grade, it's great for sixth grade when you're looking at physical sciences and chemistry.
Yeah. I like to have it like this, and then you're like smacking it, but then if you just put your hand on it, it sinks right in.
I don't know if anyone saw on the Ellen DeGeneres show, there was a giant tub of it, and they had somebody run across it.
Yeah.
YouTube that clip.
There's a YouTube clip. It's in Spanish, but or Portuguese or something. But the guy's running across it, and then one of them stops and just
falls right into it.
Dish pans and fill them up with the dish pans, have your kids take your shoes and socks off and have them run through it. And they won't stay.
You actually had them run across it? So yeah, I wanted to do that. I wanted to get like a big tub, but.
And that's a nice way to do it with trays, because then you don't need a big vat like
Yeah,
that.
I didn't think about that.
Although, you have to be careful you don't put that mixture down the drain.
Yeah.
Oh, that's bad.
Yeah, because it was garbage can everywhere.
And make sure you don't wear jewelry that day because it gets underneath your rings.
Yeah.
Or black pants. All right. Next we have Lauren and Emma. Sorry about the mess. Sorry.
Hey Lauren,
Yeah.
what time did you get up this morning?
5:30.
Oh, so you're pretty tired?
Yeah.
You want some water?
Sure. All right. Have you had a good time at this convention?
You know, I have. I've seen a lot of cool things.
Me too. I don't mind it. It's
A lot of goodies.
I know. Who has a hurt shoulder from after all the stuff they've been carrying around in these
Anyone?
blue bags?
I do. Yeah.
That is definitely one of the worst parts about it, I must say. You get great stuff, but you have to be carrying that around the entire day. Definitely good and bad evils to it.
Yeah, how was your Thanksgiving?
Good. It went fast, though.
Yeah,
It's kind of nice. College kids actually get a little bit of a break more than compared to everybody else, so.
well, I was in
a little
field,
bit
so I got
nice.
an extra long break too.
Oh, yeah.
The school had off Monday because I live in hunting country.
Yes.
Yeah, so when are we weight in water. And
Looks like this.
it looks like this, and we find it in diapers. So, we had a little trouble finding it in the diaper. So I'm going to demonstrate where it is in the diaper.
Because a lot of people might think as soon as you rip open the diaper, there's like a little cotton fiber in diapers, like the cushion part of it.
That's
Not
not it.
that.
Okay, so there's the cotton layer. It's all fluffy, right? Underneath that layer, there's a very thin layer with some crystals that are stuck to 2 layers. See it? And all you do is open it up and brush it out. Or do you want to pass around the...
How many diapers did you have to open to?
It's really not that much. Actually, it's pretty crazy if you feel the top of it.
Like 5 or 6 diapers?
Yeah, it's kind of like,
Sometimes
it's a very mushy feeling that you have on
It
top,
feels sticky,
but
but
it's
dry.
dry, so it's very, so it depends, you have to find the right ratio before you do it, depending on how much water you're gonna put in compared to the actual stuff that you have. So then when you push on it, it compacts, and as long as you don't break it, like say if you would like shake it around or do anything like that, it works out pretty well. But then if you put too much water compared to the actual soak up, like a diaper would if you had too much in the diaper, it breaks. A lot of times this is great for kids if you want to act like you're trying to pour it on the head or throw the water at them, because for the most time, if you just do the original first time we did it, it's not going to come out, and kids are they don't realize you have it in your cup. And that's the best thing because you have to use styrofoam because they can't see all the white that's in the container.
Even if you want to show it to them beforehand and have this in there, it's a white powder, so they really can't tell
That it's
that
on
it's
the
in the
bottom
bottom of it.
surface.
And you only need about a tablespoon to soak up all the water I poured in there.
Yeah. For 1 tablespoon, it's supposed to equal 8 ounces of a liquid. So.
Any questions?
That took a lot of choreography for her to have that lose hers the same time she said you lost it. So.
Yeah. And
You can buy that chemical.
Yeah.
Yes, you
there's
can buy
there's
it
a website
online.
on here. You can order the chemical instead of opening the diapers.
A teaspoon,
but diapers are more.
teaspoonful of it works perfectly. If you fill the cup up to the very top, it's a perfect mixture amount to be able to tip it without it falling.
And as you can tell, we were trying to talk for a decent amount because it takes a few
Takes a couple
seconds. Because
Right.
in the bottom, if you hadn't seen it before, we only filled it up maybe to here, if that. So it takes that time to have to fill up the entire cup when it absorbs the water. So you have to kind of distract your children while you're doing it another time, and then you go back to actually having to drink it.
Yes, Maria?
If you use like juice or something that's like not clear liquid, do the crystals change colors?
I haven't tried. Does anybody have any
Will it
juice?
work?
Yes.
Yeah, you got your
Look at that.
You said Gatorade in there.
See, there's some good inquiry for you.
Can we use yours?
Yes.
Okay.
I'm nervous.
You got all the colors you need.
I know.
Does anybody want to try it?
Not over my head.
No?
We'll let you.
Yeah, they've never done it before with grape juice, but they want
All right.
somebody to try it.
Ready?
That's enough. It's not working.
Doesn't look like it's...
I think the
Even absorbing
contents
it.
of the,
Apparently the sugar and other ingredients in the juice.
yeah, it must be the ingredients in the
Prevent the,
juice that are
absorption.
affecting it,
It's absorbing it a little bit.
but nothing to the
Nothing
amount
compared to
that,
the water.
That's a
We'll have to come back to it.
Try the Gatorade.
which is,
The red.
oh, the red? Yeah.
I mean, it's not to be goofy, but he is in all water. It's a lot of water, but
Yeah.
there's, yeah.
But you know, if you
There's
put
also
some of
the
that in a
fiber
swimming
material
pool,
in there.
That's right.
it's like that gel.
No
way.
Yeah.
My husband works for a duck company, and they actually put it in
And you can ask them,
whole swimming
when you
pool.
flip it over and nothing comes out, you can ask them what happened to the water. Some of them will say it evaporated, or there's a hole in the cup, or...
It's a fake bottom, but
It's
Yeah,
actually
just,
starting to
just,
go
you know, just,
That's so cool.
Yeah.
Wait, what happened?
That's like chemical manufacturing.
my husband works for Procter & Gamble, and they make diapers. So you put a certain amount in, like above ground swimming pool, you change the.
Okay, so after some time, it actually did
So if you don't like your
absorb.
neighbors very much,
Exactly.
over there at night. it's hard to break it apart into the, the powder that becomes easily absorbed.
Very cool.
Yeah.
So if you were going
Yeah,
to use
it's completely, now it's almost losing its color. So as soon as it did finally soak everything up, it just took a little bit more time to break through all the particles that were actually in there.
It actually keeps soaking it up. I'm going to walk around while I pour more in here too.
If you pour salt on that, you can liquefy it again.
Pour what?
Salt.
Salt?
Really?
Oh, breaks it.
Seems strange. You know, there would be salt in here.
Yeah, I don't know, but
I mean, maybe in excess.
we use it and we use it in test tubes, and then it's very hard to get out of the test tubes. So we pour salt on top and mix it with water, a little bit of water, and it's what gets it out. It helps to reliquify it helps to take the liquid out of the crystal.
So you can almost do that as a reverse version of this. You could start with a cup that has no water in it, pour some salt, and then have it go down.
That's what you're doing, is you're taking the liquid out of the crystal.
Okay. Okay, so it did absorb the whole cup of grape juice, but I wouldn't flip it over. Okay, and next is Lee and Emily.
Sorry, I'm trying to make them.
No, it's fine. Alright, I'm Emily. I'm Lee. And today we're going to do an experiment with bran flakes, as you can see. And what you're going to need is bran flakes, and normally the off-bran works the best. And you need a cup of water and a magnet and a makeshift stirring rod. We didn't have one, so we used a roller and duct tape. And this lesson can be used for a health and nutrition lesson, and what students are going to find is that we can get iron filings out of cereal. And a strong magnet is required. Okay, so the first thing we're going to do is pour in bran flakes. It really doesn't matter how much you pour in. Okay, and then we have to crush the bran flakes up into tiny pieces. And then after that, what we're going to do is add the water to the mixture. It's also good because they can be hands-on with it, get a little dirty. Alright, so you want to make sure that it's pretty fine. Okay? And then we're going to add the water. You just want enough water so that all of it's covered, kind of like a bowl. Okay. And
So, as she's stirring it to get the iron out, you have to stir it for a couple minutes. I'm just going to explain why the iron would be important. So iron is used in the production of hemoglobin in the red blood cells, and that helps carry oxygen to the body cells, which is why iron is important in the body. And because the red blood cells are constantly being reproduced, iron is also needed, like repetitive in the diet, so that's why it is necessary to eat iron. And students may not realize that the iron in cereal is the same iron that's in an iron nail. It's just like crushed up and put into the cereal, so it actually is the metal that they could find in the nail. So you could present a nail to them and ask if it would be the same thing they would assume as the iron in the cereal, which it is. So, do we have any yet? Kind of. It takes a little while to get it out, but
in the experiment it says it should take about 15 to 20 minutes of stirring, but it really does not take that long, just a few minutes. There's something metal on the table where else
yeah,
put it down.
kind of got stuck to a couple tables.
Okay, it should be good. Alright, so you have to get the flakes off. Yeah, show that. It's hard to see, but if you move it around, there's like little pieces. It's like a grayish black color, and you can get it to go together, and it shows like the iron. And if you pat dry the magnet, you can see a lot better. Because I was drying off the magnet whenever we practiced it, and there were actual, like, you could see more of the iron filings come out whenever it was dry. And obviously, if you stir it longer and use more cereal, you're going to get more out. And part of it was that you could use the box and have students try and find as much iron as it says on the serving size for each bowl of cereal. And
that students might ask is, or possible questions to ask the students would be, do you think there's less iron present in cereal than stated on the box? And is it possible that the magnet won't draw out any iron at all? And you could do it with, have one magnet that's not as strong, one that is to show them the difference, that you really do need a strong one to get it to come out. Everyone get to see it? Did everyone? Oh, did everyone see it? Does everyone want to see it? Okay. Did you show her? Yeah. Yes. Yep. All right. And then up next we have Allison and Dana.
Can I ask a
Oh,
question?
yeah.
I'm just curious. Is it necessary to put the water in if you just crushed it up?
We didn't try it without the water, but that's what it said in the experiment, that you
Right.
should put water in it.
The one thing I'm thinking is kids might think, sometimes things when they're wet will stick, and they may not find that it's a magnetic attraction. I don't know. I mean, I haven't ever.
Okay, while the next one's up, why don't you dump that in the garbage can, put some dry stuff in, crush it,
Okay.
pulverize it, and dry it.
Okay.
And we can go back to
Thank you.
Oh, but if it's wet, you could, I'm sorry, you could let it rust in a matter of a couple days, like a steel pad, and it would be, only take a couple days to rust.
I actually did this in elementary school with cereal or with Cheerios, and we just crushed it up in a bag. Then we took the magnet against the bag and pulled them up.
And it was just dry.
Yeah, just tried.
All right. Thank you. Thank you.
Hello, I'm Dana,
I'm Allison.
and we have our event, and we'll say the name of it later. And as you can see, I have a regular ping pong ball and a regular hairdryer. Can anyone tell me what would happen if I were to put this over the top and turn the hairdryer on? Any prediction?
The ceiling.
The ceiling?
It's gonna burst into flames.
It might melt.
Might melt? That's not the
You have a
cooling
hover.
part of it.
Okay, so what's happening here is the hairdryer creates an airstream that has enough pressure to hold the ball up, but it also has equal pressure all around the sides of the ball, so it's enough to hold it in. And you can even tilt it a little bit with this hairdryer, and it will stay within that airstream. And the actual name of this descriptive event is called Bernoulli's beach ball. And so the next thing we would do in the classroom, we don't have a beach ball and a leaf blower, but we would ask the students, now what if I put a beach ball here? And obviously there's not enough air to hold a beach ball up. So then you can bring out the big guns, and you bring out the leaf blower. And if you do it outside, you can even do it in the classroom. Dr. Snyder did it in the classroom for us. But you can control a beach ball all around in the air with a leaf blower. So that's Bernoulli's principle.
I've done a variation of that with the 6th graders in our physical science class, where you have a can that you put on the table, about a soup-sized can, and then have a lit candle behind the can, and you tell the kids that can they blow out the candle by blowing on the can, and they don't believe that they're going to be able to do that. You have to make sure that they're level with the can. So if this, whoa, no, I'm not using that one. So if this were the can and you have your candle over here, you have to have the kid position themselves so they cannot see the candle behind them. So you know they're directly in front. They blow on the can and the flame goes out.
Another really cool
they
one.
love it. They absolutely love it.
Another cool one that I saw in my high school physics class, there was 2 light bulbs hanging with some space in between, and our teacher said, if I blow in between them, what's going to happen? And everyone thinks the light bulbs are going to go out, but they actually draw together.
You can do that with paper too, with books.
Right.
Put 2 books on paper on top, and offer the kids a $10 bill, they blow the paper off the books.
Right.
And they have to blow, same thing, blow through the hole and pulls it down.
You can do that with the bendy straw and cheese puff, and have the kids blow and put the cheese puff on top, and they can balance it off.
That's cool. I never even thought of that.
And you tell them that you spit on the cheese balls before you give them to them, then they don't eat them.
Yeah.
You know all the tricks.
Yeah, everyone knows all the cool tricks. Well, thank you. And up next we have Austin.
All right, everybody. She said my name's Austin. And today we're going to talk about energy a little bit. So to start out with here, I'm going to attempt to bounce on this table a racquetball and a ping pong ball, as you see here. This is just a normal racquetball and ping pong ball. Does anyone have any predictions on which one will bounce higher, lower? Will they be the same? Anything? No, pretty indifferent, just, you know.
I don't know.
Racquetball.
What are the properties of a racquetball? Is it solid? Is it, I don't know.
Here, tell everybody what you think.
It feels as though it's got air in it.
Yeah, it is. It's hollow. It is hollow, if that's what you're asking. It's not like a golf ball or anything. There's not rubber bands on the inside. All right, so I'm going to drop it from above my head, same height. It's going to hit the table and bounce. Anyone see a difference? Pretty slight? Yeah, a little bit better with the racquetball. Okay. So what forces are acting on the ball?
Gravity.
Gravity. Very good, very good. And because of the elastic material that these balls are made out of, it causes them to compress when they hit the ground and then bounce back up. And the racquetball bounces higher because it has a higher elastic material. It's more elastic than the ping pong ball. Now I have a half of a racquetball. What do you think will happen when I bounce it? Anything? Just like this. Just drop it. Will it bounce? High, low? A little bit? A little bit? Teeny bit? Okay, we'll see. Pretty uneventful right there, huh? Nothing much. It's because it doesn't have enough pressure to, or it can't compress fully and then bounce back up because it is cut in half. It's not round. There's no air on the inside to compress. All right, now I'm going to put it inside out. Anybody have any predictions what's going to happen now? Pop higher? Okay, so higher than the first time? All right. Very good, very good. That's a very good prediction. All right, so why does it do this? Why does it come higher than the point that I dropped it from? Okay, good, good. Anybody else? Yeah.
You used a lot of energy to invert it, and you allow that energy to be released.
Perfect, perfect. So what I did is, there's elastic potential energy in all the balls that I used today, and then when I turned this inside out, I added mechanical energy to it, and that kind of maximizes the potential for the energy of the ball. And before I end, I just have a little trick. This just looks kind of cool. It's not really part of the discrepant event, but let's see this here. I didn't mean to hit her. That's supposed to hit the table.
That was perfect. You should have never done.
Now that your attention is directed this way, we have Carissa and Trisha.
Well, now that I got into the air, we're ready to go, I guess. I'm Carissa.
I'm Trisha, and our discrepant event is the chemistry of coppers, where we're going to investigate what will happen when you put copper coins into various liquids.
We're going to put them in the liquids now so they have enough time to, and then we'll explain. Okay. When you do this event, you need, the more pennies you have, the better, because in case that doesn't work or you drop a penny fully in the liquid, then you have extra pennies. And you have to make sure the pennies are all about the same like color and tarnish. So we picked some, if you can see, they're not real tarnish, but they're a lot darker than clean pennies, that's for sure. And then you can pick as many household liquids as you want. We picked 3 of them. We're using just a regular apple juice, some whitening mouthwash, and distilled vinegar. And you need like a towel to wipe the pennies off with whenever you're done.
So we just put a little bit liquid in each. You don't need that much because you don't want to put too much in that it covers the whole penny if you can. And you just need a separate container for each. And you put 1 penny in each, and you want to try to place it sitting up so half of the penny will change and you can compare it to what it was before you put it in. And you have to let it sit for a couple minutes. So does anybody have any idea what will happen?
happen in any of the liquids, any of the detergents?
I don't think that, oh, the apple juice one fell, but I don't think the apple juice one is going to do anything.
Why don't you think the apple juice?
Because it's apple juice cocktail, and it's like mostly water
Okay.
and sugar.
It is apple juice.
Does anybody else have any ideas on the other ones?
Does anyone have any guess on what the other liquids are going to do?
I think the vinegar is going to clean the penny the most.
The most?
Okay.
Does anyone else have an opinion on that?
I think the mouthwash is going to do
I think the mouthwash.
It'll make it white.
Well, the thing is, they all have a little secret. They saw our before and afters. Because these take a little longer than the time we have to show you. Like, there will be a change, but we have some that I set overnight. And I was actually very disturbed to see what the mouthwash did to a penny. Because the liquid, this mouthwash is clear. And when I took it out, the liquid was like a blue color. And the penny is a really not normal penny color. Actually, there were chunks floating
Do you
through
want
the
to take the
mouthwash too.
unjuiced one around too? So
And
you
this
see
is
the
what the penny
difference?
looked like when we started.
Well, here's the vinegar. It did make a difference, but not as much as the mouthwash, but it's still pretty clean. Yeah, this is the vinegar. It made it clean, just not quite as much as the...
And this is the vinegar. I was a little disturbed to know that this is what's happening to my teeth.
Only if they're made of copper.
Still probably stripping my enamel. It's just the equate, like, off-brand whitening. It's like a pre-brush brand. Yeah, that's what that one. And it's actually even shinier than the new pennies.
Oh, this one turned out good.
And here is the half and half of the mouthwash. When we took it out, you can see just in those few minutes what it did to half of the penny.
Oh, wow. That's awesome.
You can see that it showed the stripe down the center.
Everybody, ooh, ah.
The half that was in the liquid is already noticeably a lot cleaner. The vinegar didn't really have enough time. There's a very light line down the center. It's not very noticeable. It's a very little line. The vinegar, yeah, this is the vinegar.
And the apple
Vinegar
juice.
takes a little longer to react than the mouthwash.
The apple juice didn't do anything, so her guess was correct.
And some liquids such as vinegar, lemon juice, Coca-Cola, which we actually did try this with Coca-Cola, but it took a lot longer to change. It causes them to become cleaner because they're called acids.
And when your pennies are in your pockets, the copper reacts it with the oxygen in the air, and that leaves as a copper oxide, which is the black gunk that's on your pennies.
And the liquids, like the acids, they have hydrogen in them, and they pull the oxygen from the carbon, or the copper oxide that's on the pennies. They pull the oxygen off, and they actually form a liquid. So the stuff that comes off of it is just pulled off, and it's formed into water. So then you get a clean penny afterwards. Anyone have any questions? All right, thank you very much.
Thank you.
For those that came in late, this is the fourth year that the student NSTA chapter at Slippery Rock has presented discrepant events. As part of my task, I model for them, what happens if we finish early? Everyone talks really fast because they're nervous. So I have another 10 discrepant events here that I was prepared to show, fill in time. We won't have that time, so you'll have to come back next year to see what we'll set, because we'll come back each year. I do want to end with one, though, because it addresses the issue with air pressure. And in this one, you just take a cup full of water, okay, and a piece of cardboard. I like to use some wax-covered cardboard just so you can reuse it. And you turn it upside down and you ask the kids what will happen. And you can do this with the cup empty first, and obviously the cardboard falls off. But if you let go of it this time, it shows them that air pushes in all directions. So the air pushing underneath here is holding it up, and that's why we're not crushed by the air pressure on top, because there's more air pressure here than there is pushing down with the water. Now, there's another little twist you can do to this, and let me dry this off a little bit. And I'll show you what you can do this time. Now that you've all seen what happens, okay, with the first time, how can we make the cardboard actually fall? Well, in this case, okay, we can get it to fall and keep the water there. So this gives another little twist for students who think, well, the water should fall out since this fell off. Now, based on what we learned the first time, what was pushing and holding this up? Air pressure. Clearly then, this is not involved. What's keeping the water? Okay, the air pressure again. Now the difference this time is I inserted a piece of transparency paper, just a little larger, okay, than the cup, so that you can add that other twist. All right, so that is a set of discrepant events. Everyone should have their packet and their Activity 8. Thank you for coming. I think they were more nervous that we were going to be here and no one was going to come at 9 a.m. And they were just going to sit here and perform it for themselves. So I think they did a great job, and we appreciate